All right, so second part of 8.6, we have the law of cosines. And the law of cosines is if you know three sides of a triangle, or if you know two sides and the included angle of a triangle. Now I'm going to highlight some stuff here. Here's the title of our section. You can use the law of cosines if you know three sides of a triangle, or if you know two sides and the included angle of a triangle. Now, super duper important part here, included angle. Let's focus on that, okay? I'll bring it up in the notes, but included angle is extremely important because you can use the wrong angle and mess up your whole formula. Now, there are a lot of different ways to write this formula, and they're all the same. You can say A, B, C. You can use whatever letters you want. And the textbook uses this. A, B, and C just represent side lengths of the triangle. The most important part of your formula is this first piece right here. It's the same exact formula. All three of these are the same. The A, the B, the C, they all play the same role in these formulas. We just named them different things. We just named them different variables, A, B, and C. It doesn't matter what letters you use. It's just a representation of a value. What's so important about it is that's the one side that is going to be opposite of the one angle that you know. So A, lowercase a, is the side length over, or sorry, not over, opposite of this angle right here. Notice it's capital. Lowercase a is the side, uppercase A is the angle measurement that's opposite of the lowercase a side length. In this formula, B, the lowercase b, is the side opposite of this angle measurement that's represented by capital B. Lowercase c in this formula, lowercase c, it's the opposite side of angle C, the uppercase C. So I'm going to reiterate, I do not care how you write out your formula. It's up to you. Most triangles aren't even going to use A, B, and C. On this sheet, they will name the triangles A, B, C, like triangle ABC. Those are the vertices of the triangle. But if you come across a triangle with D, E, F as the letters of the vertices, then you have to know which angle measurement associates with the side length that you're given. So here's what I want to do. I'm just going to go into these little examples and highlight stuff with colors so you can see where they came from. So in example 1, I'll use the green pen first since that's what I had in my hand. Let's see. We'll say this c squared in our formula right here is the side length opposite of that one angle, 48 degrees. Okay? So I'll highlight this uppercase C in our formula, green, along with the side that's opposite, green. Notice, c squared is c squared because we don't know what it is. All we know is that it's c. Okay? 12 squared and 10 squared, they just jumped out of nowhere. Well, all they are the other side lengths that we know. 10, there's 10 for this side. 12 for this side. Okay? No big deal. That's where this lowercase a and this lowercase b comes into play. It does not matter which one you put in for a or which one you put in for b. It's kind of like that Pythagorean theorem, you know, like the only thing that mattered was the hypotenuse. Well, the only thing that matters really what you plug in is the side opposite of the angle. Now, 2AB, right there, notice the AB show up again in blue. So, according to this little example, they made A12 and they made B10. You could switch these around if you wanted to. I don't care. I'll underline that in blue, underline that in blue, underline this 12, this 10 right here. There they are. Okay? Now, all the numbers are plugged in. There's different ways to calculate this. You can, if you're really good with your calculator, plug it all into your calculator correctly. But you got to make sure you're using these parentheses correct, all that good stuff. Make sure you're using the right trig function, etc. So, notice I'm going to stick with my green for the side opposite of the angle given. And notice, there's my angle in green, 48 degrees. C, capital C at that. All right. With all this said, the textbook likes to use the calculator. I'll use red to represent this big radical. We found the square root of all of that because at the end of the day, you still have to find the square root of c squared to get regular c. So find the square root of c squared, and you end up getting c. So if you square root one side, you have to square root the other side, which is all this stuff. You end up getting 9.1. I'm going to show you in these practice problems, we're just going to kind of skip down to those practice problems, and I'll show you the way I like to work it out. But once again, if you like to work it out in your calculator because you know you're confident, you're feeling good about plugging all this in correctly, go for it. I don't care. All right, here we go. Number 1. You know what? I'm going to actually use a separate sheet of paper for all of this. If I can find one. Here we go. All right. Now, once again, I'm going to try to stay highlighted here in the corresponding parts. I can maybe have to zoom out just a little. Here we go. Autofocus kept messing up on me. Okay. All right. The one angle that we have is 62 degrees. And the side opposite of that is x. So, for this sake of the triangle, A is our angle measurement. So I'm going to go with the formula lowercase a squared equals I'm going to recognize the other two side lengths, 14 and 12. They do not matter which one's which one is b squared or c squared. So I'll just plug b squared and c squared for our formula. We'll make those blue. And I'm going to stick with the blue pen because the next chunk of the formula repeats b and c there. And then back to red, all of this times cosine of our angle measurement, which is 62 degrees. So, now I'm going to plug and chug some of our numbers in. A squared is going to be represented by x, or the A will be represented by x, so I'll make it x squared. B and C, I can make those 14 and 12 minus 2 times 14 times 12 times cosine of 62 degrees. Alright, here's how I work it out, just so I can keep up with all the little pieces. I've got 14 squared plus 12 squared. I type all of that into my calculator like that. And now push equals. I get 340. So this piece right here, all of that is 340. And the next part, I'll just put my minus symbol. And I'm going to multiply, I'll bring this minus symbol down. I'm going to multiply all of that in my calculator. So I've got 2 times 14 times 12 times cosine of 62, and I get 157.74, etc. Just go 2 decimal places, 157.74. Bring down x squared. 340 minus 157.74 equals, I subtracted those two numbers there, and I got 182.26. So, last step. Find the square root on both sides. No equal sign. You hit the second button, then the x squared button, 182.26, and approximately 13.5 is my side length. Yeah. All right, number 2. Locate the angle. It's located at B, so we can make lowercase b squared equals a squared plus c squared minus 2 times a times c. It's just the other two side lengths. Doesn't matter. Times the cosine of capital B. Remember, the beginning is, where's the angle? What letter represents the angle? That's why I start with B. The lowercase b will be represented by 10. Oh, and I should have made this red, actually. This should be red because it's representing the important parts. Sorry about that, folks. All right. So, 10 is the side opposite of that angle that was given. The included angle, by the way, I forgot to mention that. The included angle, it's between the other two side lengths. The angle is created by those two side lengths. So This means included. It's in between these two values that we know. Okay? So if I were to choose this angle right here, that's not represented by B, so that's not the included angle that I wanted. So when it says included angle, it means the angle that has a side opposite and it's created by the other two side lengths, or the blue lines if you want to. So, moving on. B will be represented by 10, the side opposite. So we've got 10 squared. If you want to go ahead and write cosine of your angle, that's fine. It's up to you. Now the angle is represented by x. That's okay. We just don't know the angle. We'll do a little fancy trick at the end. We'll be good to go. The other two side lengths are 12 and 11. I've got 11 squared, 12 squared, minus 2 times 11 times 12, times cosine of x. Now the way we multiply everything out is going to be pretty close to what we did last time, but it's going to be a little different towards the end. 10 squared is 100. All of this I can punch into my calculator. 11 squared plus 12 squared equals 265. Bring down my minus symbol. And then 2 times 11 times 12. I need to focus on this part right here. Because the 2, and 11, and the 12, if you try to multiply cosine of a variable, it's not going to really work out. Because that's not a value. 2 times 11 times 12 is 264. And then bring down your cosine of x degrees. Okay, here's where people mess up every single time. If they were to mess up. They want to say 265 minus 264 is 1, and then times cosine x. You are not allowed to do that based on PEMDAS. Parentheses, exponents, multiplication, division, adding, and subtraction. So, this right here, 264 times cosine x, that is being multiplied together. So if I try to subtract this first, we're breaking the rules of PEMDAS. So don't do that. Okay. What we got to do is, I want to subtract 265 to the other side of the equation. Please don't do that on the same side of the equation. Drives me crazy when kids do that. Minus 265 from 265, that cancels. Subtracting from 100 there. 100 minus 265 is negative 165. And that's equal to, bring all of this down. Negative 264 cosine of x degrees. Now, if this were to say negative 264x, to get x by itself, you would divide by negative 264. It's the same difference. The only difference is the trig function cosine is just there. So to get all of this together, leave it alone here, divide negative 264 on both sides. And we're left with cosine of x is isolated, is equal to negative 165 divided by negative 264. So, from the trigonometric section that we started off with, the trig section we started off with, the very beginning, when we had to find an angle, we had to use a special button. And x is being represented as an angle, so we have to use a special button. That special, amazing button is the second button. Get ready to use it. So, right here, we're going to type second, our trig function, which is cosine. There's our to the negative 1 power And we'll say negative 165 in our calculator divided by negative 264. And we get 51.317, blah, blah, blah. 51 degrees approximately. Let me do my approximately symbol. And we have our angle. Now, go try number 3, 4, 5, and 6 with a partner, and I'll be walking around to help you out. If you have any questions, just let me know. You may refer back to your devices if you need to rewatch this video.